So we've been working on writing equations for exponential equations. And so what we're going to do today is practice that again, looking at the transformations to help us, and then as well as identifying our key features like domain, range, x-intercepts, y-intercepts, asymptotes, and so on. So if we take a look at our first one here, a couple of things we should notice. One, we know it's an exponential equation because of the shape. We can also see as x increases, the y's decrease, so it's a decay function. We also know a couple of key features by looking at our table. We can identify our y-intercept at 0, -1. We also know with this function, because of the way that it's facing, it's been reflected over the x-axis in order to achieve this result. So that means it's going to impact our a value for the equation. That's going to have to be negative. And as of right now, I have not shifted it up or down because my asymptote is still here at 0, so I don't have to worry about that. We're going to take a look at the changes of the outputs because we have -1/3, -1, -3, -9. And so if I'm looking as I'm proceeding along from one to the next, I can see that I'm multiplying by 3 each time. So that's a clue as to what the base for my equation should be. Now, if I want to check, I can take any of these x values and put them in and make sure that when I evaluate it, I'm getting all of these out. And so if I put 0 in, we're going to have a 1 here times negative gives you the -1. If I put the 1 in here, that would be 3 times the negative. You've got your -3. If I put the 2 here, that's 9 times your negative is your -9. Same thing if I put the -1 in here, that would be 1/3 times the negative, that's your -1/3. So I have the correct equation, I just have to talk about the key features. So we know with our exponential functions, the domain does not change. It's always -infinity to +infinity. Now what we have to be careful here is the range. Because it's been reflected over the x-axis, the lowest it's going to go is -infinity. And the highest it's going to reach is something close to 0, but not including it. Because I have the asymptotes in play, I don't have any x-intercepts. The equation for the asymptote has to be y = 0. So that would be everything that I need to talk about my exponential equation here. Let's take a look at another scenario. So your next graph and table are the following. And we can say, well, what do we know about it? We can see based on our graph and the table, as x increases, your y's increase as well. So this is going to be an exponential growth. We also can identify a y-intercept in the table as well as our graph. And we can see our asymptote is now here at 3. So normally the asymptote's at 0, but we can see it's been shifted up 3 units. So there's a lot of key features that we can answer at this point in time. We have the asymptote here at 3, so we know the equation is y = 3. We talked about it already being growth. We've got the coordinates for the y-intercept at 0, 4, and because we shifted everything up 3 units, I'm not going to have any x-intercepts. We know the domain for your exponential functions would be from -infinity to +infinity, and our range, the lowest we can do is approach 3, but it's never going to reach that value, but it will continue on to +infinity. So we can add a lot of that information to what we have just by looking at the graph. The only thing that's missing is the equation, but we know something to get us started about the equation. Because we shifted it up 3 units, we know the k value at the back of the equation should be a +3. So I've got that vertical shift there. Because I shifted everything up 3 units, what I want to do is now think about moving it back down 3 units so I can look for the pattern of the outputs. If I'm taking away 3 to compensate for that vertical shift up, these were the original outputs I was working with to help me identify the base. So I want to think about how can I move from a half to 1 to 2 to 4 to 8. So as I'm thinking about moving along, I know I can see that I'm doubling everything I had before. So I have a multiplier by 2. If you forgot, you can always go back and take the current divided by the previous. 8 divided by 4, 4 divided by 2, 2 divided by 1, 1 divided by 1/2 to help you. So I've got my base here. So if I want to check to make sure I'm on target with my equation, I can take these inputs here, put them into my x value, and evaluate accordingly. So let's just try 1 or 2 together. If I put 0 in for x, we know 2 to the power of 0 is 1. 1 plus 3 is 4. I'm on target. Let's try the 1. 2 to the first power is 2. 2 plus 3 is 5. I'm on target. So I know I have the right equation for my transformed function. Let's try one more together. Here is our exponential function. By looking at our graph, we know a lot of information already. We can see as the x's increase, the y's decrease. So this is going to be a decay function. I also can see from my table and my graph the y-intercept. That's at 0, -3. I also can see that I have a vertical shift down with my function, because normally my asymptote is here at 0, but now it looks like it's down here at -4. So I'm going to draw that in, and I can put that into my equation to show, hey, I lowered it by 4 units. My k value should be -4. Because I lowered it, I now have an x-intercept that I can see here on my graph. Let me point that out a little bit more here. And I can also see it here in my table where the output is 0. So I have an x-intercept at the coordinates -2, 0. The domain we know for our exponential equations are always from -infinity to +infinity. But because I lowered this down, my range is going to be impacted. The lowest I can approach is here at -4, and I can use everything greater than that. So I have to show that everything greater than -4 is okay for the range. So we've got everything for the key features identified just by looking at the graph in our table. Now we've got to figure out, well, what's the base for this equation going to be? I lowered everything by 4, right? So I have to think about putting it back to where it was to figure out the base, the multiplier for my equation. So I'm going to raise all of these values by 4 to see what they were originally. And again, I raised all of these values by 4 to get this here. So I'm going to look at my values. How do I go from 16 to 8, 8 to 4, 4 to 2, 2 to 1, 1 to 1/2? I can clearly see that it's a multiplier, right? We know it's exponential. If you're unsure, take 1/2 divided by 1, 1 divided by 2, 2 divided by 4, 4 divided by 8, 8 divided by 16, and I can see that my multiplier is going to have to be 1/2. So I can put that into my equation, 1/2 to the power of x minus 4. I can also check by taking any of these input values by putting them into my equation to make sure I get the correct output values that go with it. For example, let's start with 0. 1/2 to the power of 0 is 1. 1 minus 4 brings me back to the -3. I can do the same thing with the other one, where I've got 1/2 to the -1st power. That's the reciprocal. So you've got 2. 2 minus 4 is -2. So I've got the correct value. If you want to put the 1 for the a value, you can. There's no vertical stretch going on, so it's not necessary. So either of these formats would be okay for your functions. Now that we've done 3 functions together, you're going to have 3 to do on your own. So as you look at the next 3, you can take a look at the graph. And again, a lot of this you can answer right away, right? We should be able to tell if it's growth or decay, where the asymptote should be, any x or y intercepts. We should be able to write the coordinates. You even have a table here to get you going. You can also write the domain and range. What I would remind you to look at when you're looking at the equation is look for the vertical shifts first, because you have to compensate for them just like we did on the last problem. So if you see things that you move down, shift them back up to where they originally were to find the multiplier for your equation. And vice versa. If they were shift up, shift them back down to see where they were and work on finding the multiplier for your equation. Class Kick is programmed to check your equations and all of your key features for these next 3 graphs that you're working with. So this is the first one, this is your second one, this is your third one. So as you're working on your problems, type into Class Kick to see if you're on target. If you have any questions, use the raised hand on Class Kick, and I will address those with you through that platform. We'll see you for the next lesson.